Now we will discuss question 3. Given x and y are two events with probabilities px equals to 2 over 7, p probability of x given y prime is 3 over 7, and probability of x intercept y is 1 over 21. So in order to interpret our data, it's easier for us to do our table first. So this is the probability of x, and here is the probability of x prime, and here is the probability of y, and probability of y prime. And we know probability of x intercept y is 1 over 21, and probability of x is 2 over 7, and probability of x given y prime we'll find later. And here is one, the total probability of x and x prime and probability of y and y prime is equal to 1. So with this table, we can find probability of x intercept y prime. We take 2 over 7 minus 1 over 21 means 5 over 21. And the rest of the data, we can't find it. And we'll find it by this information, probability of x given y prime. As we know, probability of x given y prime is equals to probability of x intercept y prime over probability of y prime. And probability of x given y prime is 3 over 7. And probability of x intercept y prime we have 5 is 5 over 21. And probability of y prime we didn't find it, and now we can find it. And after substituting the value, we'll find the probability of y prime is equals to 5 over 9. And we can find probability of y prime is 5 over 9. And we can find the probability of x prime intercept y prime. We take 5 over 9 minus with 5 over 21, and we will get the answer 20 over 63. And the probability of x prime we also can find. We just take 1 minus 2 over 7, and we will get the answer 5 over 7. And probability of x prime intercept y prime, with the data, we also can find. We take 5 over 7 minus with 20 over 63. We'll get 20. We'll get 25 over 63. And probability of y we also can find. We just take 1 over 21 plus with 35 over 63, and we'll get the answer is 4 over 9. Yeah. And then after we obtain all the data in the table, then we can find find probability of x union with y. Probability of x union with y is equal to probability of x plus with probability of y minus with probability of x intercept with probability of x intercept y. Okay, probability of x we have is 2 over 7 plus with 4 over 9 minus with 1 over 21, and we'll get the answer is equal to 43 over 63. Okay, then we will proceed to number 3a I. 3i we have solved. We get the answer. So it's 43 over 63. And for 3ai, we want us to determine whether x and y are independent events or not. So if we want to know the events are independent or not, we need to find the probability of x intercept y and probability of x times the probability of y. So we'll find probability of x times the probability of y first. Probability of x, we have probability of x is 2 over 7, probability of y is 4 over 9. So we just sub the value into it. And we'll get the answer is 8 over 63. Or for probability of x intercept with y, in our table we have x intercept with y is 1 over 21. So we can conclude that probability of x times probability of y is not equal to probability of x intercept with probability of y. So therefore, event x and y are not independent. That's it.
Before we start, relate event affected by COVID-19 is I, event that shows symptom is S. The question state that person being affected by COVID-19 is 0.7. So we can get 0.3 who not being affected by COVID-19 because total probability must equal to 1. So 1 minus 0.7 is 0.3. Next, people have been infected by COVID-19 and free any symptom is 20%, which is 0.2. From that, we can get 80%, which is 0.8. who been infected and show the symptom. Moreover, people who not infected and show the symptom is 0.1. So people not infected and free any symptom is 0.9. Next, we can get the probability of I and S is 0.56. Probability of I and S prime is 0.14. And probability I prime and S is 0.03. Lastly, probability of I prime and S prime is 0.27. Then we put this information of tree diagram into the contingency table. Then we move to BII. We refer the probability free of symptom from the tree diagram. Thus, probability S prime is 0.41. Next, BIII. The question can be written in this way: probability of not infected if free of symptom. It is equals to probability of I prime intercept S prime over probability of S prime. Then we find this value from tree diagram. For I prime intercept S prime, it is equal to 0.27, while probability of S prime is 0.41. Thus, the probability of the villager infected by COVID-19 if free of symptom is 27/41.
Following so today we are going to solve the problem for question number 1. In 1A, we need to construct box and whisker plot. Identify the outlier and interpret the shape of data. To construct a box and whisker plot, do you know what data we need?
We need to find first quartile, second quartile, third quartile, upper inner fence, and lower inner fence.
Yes, you're right. First, we construct stand and leaf diagram to arrange the data in ascending order. Then we can start the calculation. For first quota, which is Q1, we need to times the total number with 1 over 4, and then we get the R observation is 8.25. Since it's not an integer, so we should run up the R observation. For the Q1, it will be at the 9th observation. So the first quota will be 37. While for R2, we need to times the total number 33 with 1 over 2, and we will get observation 16 observation. And since it's not an integer, we need to run up to 17 observation, and Q2 we will get the answer is 48. While for R3, we need to times the total number 33 with 3 over 4, and we will get 24.75 observation. Since 24.75 is not an integer, so we will round out to 25, and we will get the answer Q3 is equals to 68. And then we will calculate the upper inner fence and lower inner fence. For upper inner fence, we will substitute Q1 and Q3 into the formula, and we will get the answer is equals to 114.5. And for lower inner fence, we will substitute Q1 and Q3 into the formula, and we will get the answer for lower inner fence is negative 9.5. After getting all the information needed, so we can draw the box and whisker diagram. And we need to plot the minimum number, Q1, Q2, Q3, maximum number, and lower inner fence and upper inner fence. After that, we will determine the presence of outlier.
Since the maximum and minimum value of the data is within the upper and lower inner fence, we do not have outlier, right?
Yes, you are right.
Then we can conclude that the data is positively skewed because the right whisker is longer than left whisker and the median is nearer to first quartile. If the left whisker is longer and median is nearer to third quartile, the data is negatively skewed.
Yes, I believe that you are right. I also want to add that there are many advantages of box and whiskers plot. It not only can show the squareness of the data and outliers, but also show clear summaries of the data, so we can handle large data easily, as well as enable us to compare data set quickly.
Yes, both of you are right. Next, we move to 1BI. We need to calculate mean, mode, and standard deviation for the data. Before we calculate, we do a table to analyze our data first. In the table, we calculate the midpoint, cumulative frequency, and fx square. Fx.
Sorry to interrupt. May I know how to calculate the midpoint?
It is the sum of the lowest and upper boundary divided by 2.
Oh, okay.
Yes, Shaira is right. After construct the table, we will calculate the sum of fx and fx square, which is needed later. Fx and fx square, and then we will calculate the mean by dividing the sum of fx with sum of frequency, which is 30. The mean for the data is 282.83. After that, we move to the median. Since this is group data, we need to find the median class first. So we need to divide 30 with 2, and we'll get the median is 15 observation. And according to the cumulative frequency, the median class is 200 to 299. Then we can calculate the median, which is equals to 274.50. Lastly, is standard deviation. First, we need to calculate the variance first. For calculate, we just need to substitute the value inside the formula, and we will get the variance is 22988.506. Then we will get the standard deviation, which is equals to the square root of variance, which is 151.62. Then in BII, we need to find the Wilson coefficient of skewness, the formula that we will use. And after substitute the value that is calculated in BI, we will get the answer is equals to 0.164.
We still have another formula to calculate Pearson coefficient of skewness, right? Which is difference of mean and mode divided by standard deviation. Can we use that in this question?
Yes, of course you can. If you find the mode, then we need to comment on our answer. Let's give Alina to conclude.
If the percent coefficient of skewness that we get is positive, this means that our data is positively skewed. If we get negative, our data is negatively skewed. And if we get 0, this means that it is a normal distribution. So since our answer is positive, the data is positively skewed.
Yes, great. Thanks all of you.